Cloud technologies will improve the performance and efficiency of mobile networks. Many studies have predicted that the traffic demand in mobile networks will dramatically increase in the upcoming years. But how can mobile networks deal with such an increasing load? European researchers are developing a new technology that leverages cloud techniques to improve the performance and efficiency of mobile networks. The increasingly widespread use of smartphones capable of streaming audio and video is leading to an exponential growth in the volume of traffic carried through mobile networks. Such growth is expected to continue in the next few years, with forecasts that anticipate a 100-fold increase in traffic by 2020. In line with these forecasts, the Digital Agenda for Europe (DAE) has set the goal of providing data rates of at least 30 megabits per second to all European Union citizens by 2020, with 50% of them accessing the internet with at least 100 megabits per second. Given the current trends on accessing the internet from mobile devices, these goals cannot be achieved with wired connectivity only. Funded research projects are investigating new technologies that substantially increase the capacity of mobile networks to satisfy future traffic demands and meet the DAE goals. To provide such an increase of the mobile access capacity, very dense and low-power small cell networks with a very high spatial reuse need to be deployed. However, this deployment poses several challenges. First, small cells require a high degree of coordination to fight inter-cell interference. Second, heterogeneous backhaul solutions need to be used to connect the small cells to the core network. Third, as a result of spatial and temporal traffic fluctuations, there is a high likelihood that many of the base stations carry no or very little traffic, leading to a very high energy waste. Centralized processing provides a very promising approach to cope with many of the above challenges. By leveraging high processing capacity, such an approach allows implementing efficient interference avoidance and cancellation algorithms across multiple cells. Additionally, by exploiting the fact that the data from all base stations is centralized in the same location, it provides the ability to globally control the access network, which can be used example given, to selectively turn off those base stations that are not needed, resulting in substantial energy savings. Centralized Radio Access Network (RAN) has recently attracted considerable attention as a technology that leverages cloud techniques to centralize the computational resources of the mobile network. With this technology, multiple sites are connected to a central unit, the cloud, which takes care of performing all the baseband processing. Currently proposed centralized RAN solutions have been designed with the assumption that the backhaul is composed of fiber links, and as a result such solutions require very high bandwidth connectivity to the cloud. However, this is very unlikely to hold in future very dense deployments, which will rely on wireless, limited bandwidth, backhaul links. Thus, a trade-off emerges between the benefits resulting from centralized processing in the cloud and the bandwidth consumed in the backhaul. To address the above issue, the European project iJoin has proposed the novel concept of Radio Access Network as a Service (RAN). RAN as a service provides an optimal split of the RAN functions between the mobile network and the cloud that takes into account not only the computational benefits of using the cloud but also that backhaul bandwidth costs. Specifically, by analyzing the computational requirements as well as the associated backhaul bandwidth demands of the various RAN functions across the several layers of the protocol stack, the iJoin architecture places each function in the optimal location, the radio access network or the cloud. Another major challenge addressed by the iJoin project is the joint design and optimization of the backhaul and the radio access. Indeed, in the context described above in which backhaul bandwidth cost is one of the key limitations, it is very important to minimize such costs. This goal is addressed by iJoin by providing a design of the mobile network that jointly optimizes all the parts of the networks, including the backhaul network and the radio access. This contrasts with existing solutions, which optimize each part separately and hence result in a suboptimal design. With the iJoin architecture, RAN functionality is centralized through an open IT platform based on a cloud infrastructure. Among other advantages, this concept has the potential to open the RAN or backhaul market for new players, such as vendors of cloud infrastructure equipment and providers of cloud services. RAN as a service also provides the technological foundations for shorter and more efficient product development cycles due to the shift from dedicated equipment to software-based functions operated on cloud infrastructures. Furthermore, this solution will allow for a significant reduction of costs for operators, because part of the RAM computation complexity is moved to the cloud infrastructure. The iJoin project has been recently awarded by the regional government of Madrid the runner-up prize to the Best European Cooperative R&D project, which recognizes excellence in the arrangement of international collaborative activities in the R&D area. The prize has been awarded to iJoin for its focus on technology that is key for the proper utilization of a scarce and strategic resource such as the radio spectrum, and for its contribution to place the Madrid region in the forefront of scientific leadership in a highly innovative sector. The iJoin consortium is formed by major manufacturers and operators as well as leading academic partners.